All right, welcome back after the holidays, guys. And this paper that you wrote at the end of last year as a halfway mark for your IGCSE was your first bit of homework for the year. So we will go through this, work question by question, explain some of the concepts. So let's get into it. Okay, first question. So we see Hosea builds a house and then sells it for 450,000 Namibian dollars. He pays a tax of 1.5% of the selling price of the house, which is the 450,000. Show that his tax that he has to pay is 6,750. Okay, so we just want to work out the tax on this amount, which is the selling price. So to work out that, let me just find my mouse again. Okay, so we're going to work out 1.5%. So percent just means out of 100. So 1.5% of the selling price. Okay, and that is all we need to do. Let me get out the calculator and type that in. So 1.5% of the selling price, 6,750. That equals 6,750. And remember to put the units down with your answer. So 6,750. Okay, a nice easy one just to get us warmed up. Now question B. This 6,750 Namibian dollars is 12.5% more than the tax Hosea paid on the first house he built. Calculate the tax he paid on the first house. Okay, so we want to find the original value. A couple of ways we can do this. So I'm just going to show you two ways, and I'm sure there are very many other ways. So if any of you viewers want to comment a different method for calculation that you prefer, please do so. Okay, so I'm going to show two methods. The first one is the algebraic method, which I quite like, because algebra, just to me, it reads like a proper story. So I'm going to say the tax he paid on the original house was X dollars, Namibian dollars. Then increasing that by 12.5%. So plus 12.5%, which is 0.125, 12.5% of that amount is now equal to this new amount that we have, 6,750. And then I just solved this algebraic equation. Okay, so 1x plus 0.125x is 1.125x. And that is equal to 6,750. And then we divide both sides by the 1.125. So 6750 divided by 1.125. And let's see what that gives us. Again, let's put out the calculator. So we have that amount divided by 1.125, and we get 6,000. So it's $6,000. Okay, now another method we could have used would be the shorter one. I just remember getting confused when I was at school about when to put 100 on top or when below, but let's get to it. So we want to find the original amount. The original amount is missing. So from the original amount, we went 12.5% upwards. So to find the original amount, that's going to be the 100% from where we were. And the thing you're looking for, you want to put on the top if you're working with percentage fractions. So we're looking for the original, which is always the 100. And then to the original, we added 12.5%. So we can just add that 12.5%. So 112.5. Okay, and then we just times that by the 6,750. So very short, nice way to do it. Only thing for me is getting confused about, is it now going to be 100 over 87.5? Do we subtract the 12.5 from the 100? Do we put it the other way around? I remember getting confused by that, but if you don't, if you prefer this method, great. It does work out quite well, and it is very short, which is nice. Okay, so 100 divided by 112.5, and then we times that by the 6,750, and we get our 6,000. And again, if you have any other preferred methods, please write that in the comments, and we can work through that together. Okay, so 6,000 is the tax he had to pay on his first house. Question C. The house is built on a rectangular plot of land that measures 21 by 17 meters. Both of those numbers correct to the nearest meter. And we need to calculate the upper bound for the area. So to calculate the upper bound, for any calculation, or lower bound, we have to find the upper and lower bound of each individual value first. We don't first do the calculation and then find the bounds. We first find the bounds and then do the calculation. Okay, so we have area equals the length times the width. I'm just going to write it like that, length times width. So for the length, we're going to have an upper and a lower bound. So I'm going to do it like this. So I'm going to say lower bound, upper bound, and then we'll have our length and our width. Okay, so to find the bounds, let's start with the length, the 21. So 21, and it's correct to the nearest meter. To find the bounds, we take whatever it's correct to, so correct to the nearest meter. So we take a meter and divide that by 2, which gives us 0.5 meters. Okay, so that's half of whatever it's correct to the nearest thing. So correct to the nearest 1 meter, we divide that by 2, we get 0.5 meters, and that is the value we will add or subtract to the given value to find the bounds. So the lower bound would be 21 minus 0.5, which is 20.5. The upper bound would be 21 plus 0.5, so 21.5. Then we can do the same for the width. Now the width is also correct to the nearest meter, so it's also going to be 0.5 meters, so we add and subtract. So lower bound for 17 with a 0.5 accuracy will be 16.5, and the upper bound 17 plus 0.5, 17.5. Okay, now we have all the bounds. Now we need to decide for this calculation which bounds do we want to use. So we want to find the upper bound of the area. With multiplication, if we take the biggest times the biggest, we'll get the biggest area. So it's going to be upper bound times upper bound. If you're ever unsure though, there aren't that many combinations. Right? So you can just test all the bounds multiplied together for length and width. There's only 4 options, and then you see which one is the biggest. So if you're ever stuck and you're not sure, just test all of them and find the biggest one. Okay, so we're going to say area. Let's see. Let's say area upper bound. The upper bound of the area will be the upper bound of the length times the upper bound of the width. So in our case, that's going to be the 21.5 multiplied by the 17.5. Okay, let's again get out the calculator. 21.5 times 17.5. That's 376.25. Okay, so 376.25 meters squared. Okay, remember, square meters for area. Okay, I hope this makes sense. Question D. On a plan of the house, the area of the kitchen is 5.6 squared centimeters. The scale of the plan is 1 to 200. Calculate the area, the actual area of the kitchen in square meters. Okay, so important. We get given something in square centimeters, and we have to find it in square meters for the final answer. Okay, important to recognize the units that they give us. So for these ones, I like to just do straightforward ratios. Whenever something can be done in a ratio form, I like to do that. So I'll do this. Let's say we have the plan and we have the actual. We also have a length or a scale. We've got an area and we've got volume that we can work with. Okay, so the length or the scale is what they give us, the 1 to 200. So the plan is 1 to the 200 for actual. We just write actual. So we can distinguish between actual and area, and PL for plan. So that's a scale. Now, if we want to find the scale or the ratio of the areas, because we're going to be calculating areas, then we just square the lengths or the scale. So 1 squared will be 1, and 200 squared is going to be 40,000, right? So 200 times 200 squared is 40,000. So that's this ratio of the areas. Okay, now I'm just going to get rid of the volume because we don't need that in this case. So there is, whoa, that's a skew line. So here is our ratio for the areas. And now we need to find the actual values. So we know on the plan, the area was 5.6 centimeters. So you can convert this to meters straight away, or leave it in centimeters. I'll leave it in centimeters for now. And then we have to find out what the actual area is. So 5.6 to x, and the scale is 1 to 40,000. So now we can just cross multiply to solve for x here. Okay, so cross multiplying, so we multiply those two together, 1 times x equals, and then we multiply those two together. That I should probably be able to do without a calculator, but I'm a little bit lazy now. So 40,000 times 5.6 will give us 224,000. Okay, so 224,000. But now remember, this was square centimeters. Now we have to convert this into square meters, as they said there. Okay, so to convert between meters and centimeters, okay, we've got meters, centimeters. So generally, converting between these two, it's 100. Right, so from meters to centimeters times 100, and from centimeters to meters divided by 100. But as we make it square meters and square centimeters, then we just add a square here. So times 100 squared or divided by 100 squared. So going from squared centimeters to squared meters means we have to divide this by 100 squared. Okay, so divide that by 100 squared will be 22.4. But let's just make sure. Take that, divide that by 100 squared. We get 22.4. Okay, where is my pencil or pen? So equals 22.4 square meters. Square meters. Okay. Question E. Oh, the whole first question takes up quite a bit of space. But that's a common thing with the paper 4 type questions. Let's actually just go to the top. We see here it's paper 4. Paper 4 often has a couple of questions with lots of subparts. Sort of, this is Hosea building a house. And then all the questions are based on that. Give us an idea of how things work in real life, that everything is connected. Question E. The house was built using cuboid blocks, each measuring 12 by 16 by 27 centimeters. Calculate the volume of one block. Okay, so that's pretty straightforward. The volume of a cube is just length times width times height. So it doesn't matter which one is which here. We can swap these around. So we can say that's 12 times 16 times 27. Okay. Whoa. 12 times 16 times 27 gives us 5184. 5,184. And what is the units? Centimeters cubed, right? It's volume. So 5,184 cubic centimeters. That's the volume of one block. Okay. Question F, the last question on question 1. Hosea exchanges 12,000 Namibian dollars into euros to buy land in another country. And they give us the exchange rate. 1 euro is apparently 1.33 Namibian dollars in this question, although that's far off from reality. Calculate the number of euros Hosea receives. Okay, give your answer correct to the nearest euro. So again, this I can do in straightforward ratio form. Exactly the same as how we did this in ratio form. Okay, so we have Namibian dollars and we have euros. Okay, so 1 euro is the same as 1.33 Namibian dollars. Now I want to exchange 12,000 Namibian dollars into euros. We don't know how many euros. Let's call it X. And then again, we can just cross multiply to solve here. So multiply those. That's 1.33x equal 1 times 12,000. And then we divide both sides by the 1.33. Again, you can do this much shorter. A lot of this, for a lot of you, I know this feels like just common sense, what to do, what to divide or multiply. And that's fair. You can do it. You don't have to show these steps. I just like this one, doing it this way, because this works for every kind of problem. Even if there are multiple unknowns, if there are x's in different places, you can still do this and solve the equation. So this is just a safe way for me to do it. But if you see a quicker way and you're confident, please go for it. We don't want to be robots all just doing exactly the same methods for each question. We want to think and do it in our own way. Okay, so 12,000 divided by, that's not divide, that's times 1.33. So that's 9,022.56 if we round up. 9,022.56. Let me just check the number again. 556. So again, we see this 6 is bigger than a 5, so it changes the 5 to the left into a 6, because we have to round off to 2 decimal places for money. All right. So this will be 9,022.56. And this will be euros. So remember to put your units. Okay. And that is it for question 1. Let's change colors for question 2. Let's go to pink. Okay, here we have some sets, Venn diagrams. So they tell us x is an integer. And this little symbol, sort of it's a Greek Z symbol. And we call this the universal set. That's the symbol we use for the universal set. This one, right? So it covers this whole thing. Everything has to be part of the universal set. So in our case, the universal set are all the integers from 1 to 10. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is all the values we have to work with. Okay. Set A, they tell us that it's all the factors of 12. So it must be from 1 to 10, but all the factors of 12 from 1 to 10. Set B are all the odd numbers from 1 to 10. And set C are all the prime numbers from 1 to 10. Okay, complete the Venn diagram to show the information. Now, if we have multiple overlaps, we want to start from the beginning. Well, that's at least the easiest way to do it. So, I mean, not the beginning, the center, the most overlapping part. We want to start there. So we want to see, are there any numbers that fit into set A, B, and C? So a factor of 12, which is also an odd number, right? So there we already have 3. And is 3 a prime number as well? Yes. Okay, great. So we can put 3 in here. And there are no other odd factors of 12 except for 1. But 1, so 1 is a factor of 12 and odd, but it's not prime. Okay. Oh, I accidentally made a mark there. Okay, now let's do which ones fit in A and B. So odd numbers that are also factors of 12. Okay, so that'll be 1. Then 3 is also an odd number, but we already have that. 5 is not a factor of 12. 7 is not a factor of 12. 9 is not a factor of 12. So just 1 goes in here. Then let's look for this one, B and C. Okay, so what else goes in B and C? So odd prime numbers. So 1 we already used, but it's not a prime number, but it is odd. 3 we already used, it fits in everywhere. 5 is odd and prime, yes. 7 is odd and prime. 9 is odd but not prime, so it doesn't go in here. So these are the odd prime numbers. Okay. Then the last overlapping part here, A and C. So factors of 12, which are prime numbers. Okay, so 2 is a factor of 12 and a prime number. And no other, we've already accounted for all the odd numbers that are factors of 12. So non-odd numbers that are factors of 12, only 2. Okay, then let's see. What is, from all the numbers that are left, which ones fit in A? Factors of 12. Okay, so 1 is a factor, 2 is a factor, 3 is a factor, 4 is a factor of 12. 5, 6 is a factor of 12. 7 we already used. 8 is not a factor, and 9 is not a factor, and 10 is not a factor. B, odd numbers. Which odd numbers haven't we used? We've used 1, 3, 5, 7, so we still have 9 left. Prime numbers. Okay, so 2, 3, 5, 7. That's all the prime numbers, right? Between 1 and from 1 to 10. Okay, so nothing goes in here. This is empty. Now, which other numbers can we put outside that we haven't used yet? So 1, 2, 3, 4, 5, 6, 7, 8 we haven't used. And also 10 we haven't used. So those go on the outside here. Okay. So that is completed. Now use set notation to complete each statement. So 6, we have to put something here, A. So I would say the best way to answer this is saying that 6 is one of the elements of A. So we can say 6 is an element of A. Now the intersection of A, B, and C, the intersection there, we do have a value there. So we'll just write it's the set containing 3. So we can't just say 3. That's wrong. We have to say it's the set that contains the element 3. And then A intersecting with not A, or the complement of A. So where does A intersect with everything that's not A? Well, nowhere, right? A cannot intersect with anything that's not part of A. So that is an empty set. 2 ways we can write that. The symbol for empty set is this. So we'll write that. Or we could also just write a set without anything in it, an empty set. So either of those are correct. Okay, I'm just going to write the empty set symbol, because that's probably what they want you to write. Question A3, right? A3, yes. Find n of B. So what does that mean? That means the number of things, the number of elements in set B. Okay, so in set B we can count them. 1, 2, 3, 4, 5. There are 5 things in set B. Okay, so that was that for the first question. See, not too bad, right? Question B. So we have another Venn diagram. The universal set is given, and we've got set X, Y, and Z, and we've got some elements listed inside them. You use set notation to complete this statement. Okay, so the set that has only U and V in it, so this set, so this part, so telling us this, what can we say about this in relation to Z? Well, it's a subset of the whole Z. Right, so this set is a subset of this set. Okay, so subset. How do we write a subset? Like that. Like sort of an elongated C almost. A subset. Okay, now we have to shade this region, this part. What does that say? It says this area we have to shade where X intersects with the complement of the union of Z and Y. Okay, so let's start with the union of Z and Y inside the brackets. So the union of Z and Y is this. It's all of Z plus all of Y, that whole thing. So that's the union of Z and Y. Now we take the complement of that, so everything that's not here. So everything that's not inside this purple part, so everything on the outside of the purple part, where does that intersect with X? In this section here, right? That section. So that's the intersection of X with everything that's not in Z union Y. So we want to shade this whole part. Okay, I'm not going to shade it properly now. I'm just going to do sort of roughly this. Okay. So there we go. Good. And that was it for the Venn diagrams, it looks like. Question 3. Let's change colors again. Let's do dark green for this one. Okay, factorize. So this is the difference between two squares. Right, so let's just recap difference between two squares. So if we have something squared minus, let's say, that thing squared, then, actually, I'm going to make it like this. It'll be easier to understand. So if we have something squared minus something else squared, we can factor that into 2 brackets, which are almost identical. Only difference is one of them has a plus sign, one of them has a minus sign. And then what goes in the front of each bracket? Well, the square root of that thing. So the square root of triangle squared is just triangle, and the square root of square squared is just square. Right? And then if we multiply this out, we should get that back. So that's a nice, easy factorization. Difference between 2 squares. Okay, so we will have here 2 brackets. One will get a plus, one gets a minus. And then the square root of 121y squared is just 11y. So 11y, 11y. And then the square root of m squared is just m. And that's it. As simple as that. Let me just move this over here to the answer section. There we go. Okay. Write as a single fraction in its simplest form. Okay, so if we want to add or subtract fractions, we need to have a common denominator. So let's just say if we had numbers and not letters, if we had 1 over 2 plus 3 over 5, what would be the common denominator for 2 and 5? It would be 10, right? Because that is 2 times 5. So we just say 2 times 5 to get our common denominator. And then what do we put at the top? We had a 1 here. The 2 we had to multiply with a 5 to get to 10. So the top we also have to multiply by a 5. So 1 times 5. Then we had the plus. We had a 3 on this side. So at the bottom, the 5 had to be multiplied with a 2. So the 3 we also multiply with a 2. And then we just simplify. And it works exactly the same when it's algebraic fractions. So if there are letters involved, exactly the same thing. Let me show you. Okay, to get a common denominator, we just multiply the two denominators. So we're going to say the common denominator is going to be 3x minus 5 multiplied by x minus 1. And we don't want to multiply out the brackets. We just want to keep it like this. It makes it much simpler. So now at the top, we had a 4 on the left. So the 4 already has the 3x minus 5, so it still needs the x minus 1, right? Or we can think about it like we just said. The 3x minus 5 had to be multiplied with x minus 1 to get this denominator. So since we multiplied the bottom by x minus 1, we also have to multiply the top by x minus 1. Okay, x minus 1. Then we had a plus, and we had the x plus 2. Okay, so this x plus 2 already has the x minus 1, so it still needs the 3x minus 5. So it still needs to be multiplied with 3x minus 5. Okay, now the top we do want to multiply out. Okay, so 4 times x, 4 times negative 1. And then we've got x times 3x, which is 3x squared. X times negative 5, which is negative 5x. 2 times 3x, which is 6x. And then 2 times negative 5, which is negative 10. All of that is still over 3x minus 5 times x minus 1. So now we collect the like terms at the top. So let's start with the biggest exponent. I like to do it that way. So 3x squared doesn't have any friends, so just 3x squared. And then the x's, so we've got 4x minus 5x plus 6x. Okay, so 4x minus 5x is negative x. Plus 6x is positive 5x. So we have plus 5x, and then all the numbers. So negative 4 minus 10 is negative 14. So that's still over 3x minus 5 times x minus 1. And then one last thing we need to check is, can the top now factorize? Because if the top can factorize, then we have to factorize it to see maybe something can cancel out. So how would we know if this could factorize? Just by looking at it like this. Well, not just by looking, but what can we do to check? So for me, I like to say, take this value in front of the x squared, the coefficient of x squared, and the constant, and multiply those together. So 3 times 14 is 42. Then we see what are all the factor pairs of 42. So it's either 1 times 42, 2 times 21, 3 times 14, 4 doesn't work, but 6 times 7. So those are all the factor pairs. And now we check, can any combination, any of these factor pairs, if we add or subtract them, give us a 5? And no. None of these, if we add or subtract them, can give us a 5, so this cannot factorize. That means we are done with the question. Single fraction in simplest form. Okay, so again, let me just shift that to the answer section. Boom, done. Okay, good. And maybe another clue. In this case, we didn't need to do it, so I didn't mention it. But whenever we see algebraic fractions, we want to factorize each part first, if we can. So each numerator and each denominator. Factorize each of them first before continuing. It'll just make your life a lot easier. Question C, solve this equation. So it's a quadratic equation. In general, at this level, we have 3 methods to solve quadratic equations. Either factorizing, completing the square, or using our quadratic formula. And if they tell us, give your answer correct to 2 decimal places, that's a big clue that factorizing will not be possible. So then, I would suggest use your quadratic formula. But if you really like completing the square, you can also do that. It just takes much longer and there's more scope for mistakes. So let me just write down the quadratic formula. If we have this quadratic equation, ax squared plus bx plus c equals 0, then x equals negative b plus or minus the square root of b squared minus 4ac, all of that divided by 2a. And it's a nice exercise to start here and then do completing the square to get x, to make x the subject of the formula. And you'll see that is where this formula comes from. Okay, so exercise to do by yourself. Do completing the square on this at the top here and make x the subject of the formula. You will get this as a final answer, and it's quite nice to see where the formula comes from. It didn't just fall out of the sky. Some funny mathematicians didn't just come up with this and then checked if it worked. It's actually from doing the algebra that we get to this in a general case. Okay, now we have the formula, so we can apply it. So we're going to say x equals. So in this case, that's our A, that's our B, and that's our C. Right? Coefficient of the x squared is A, coefficient of the x is B, and the constant is C. So negative B plus or minus, and if you're ever unsure, you can always add more brackets. They cannot harm you. If you forget brackets when they're needed, that can harm you. So if you're ever unsure, just put an extra bracket. Okay, B squared minus 4 times A times C. All of that divided by 2 times A. Again, the nice thing is now we can just type this on our calculator. Right? One time with the plus, one time with the minus. I am just going to simplify it a little bit before we type it on the calculator. So it's negative 2 plus or minus square root. And then 2 squared is 4. The minus minus makes a plus. So we have 4 plus. And then 4 times 3 is 12. And 12 times 7 is 84. So plus 84. So it gives us the square root of 88 in here over 6. Okay. And now this can simplify even further. But let me just put that in the calculator straight away. Okay, so for the first one with the plus, we will have negative 2 plus the square root, oops, that's not working, square root of 88, all of that divided by 2a, which is 6. So 1.23, corrected 2 decimal places, right? 1.23. Where is my pen? There it is. 1.23. Now we're going to do exactly the same thing, just with a minus. So I'm just going to change that into a minus. And we get negative 1.896. Okay, so we have to round off to the 9, but the 6 is bigger than a 5, which means it changes the 9 into a 10, which means that changes the 8 into a 9. So negative 1.90. The negative 1.90. Okay. Now in this part, all lengths are in centimeters. So let's say A, B, C, D is a trapezium with an area of 15 squared centimeters. Show this. Okay, so we're just going to use these values and do an equation for the area. So I'm going to do it in 2 ways. I'm first going to do it the way that is probably on the memo, if Cambridge had to set this up, which would be to use the formula for the area of a trapezium. But if you don't like the trapezium area or you don't know it, you can also just split this into a triangle and a rectangle and use that. So let's start with the area for the trapezium. So area of a trapezium, let's actually write that out. So area of a trapezium equals, so it's half times the sum of the parallel sides times the perpendicular height. Okay? So that just means perpendicular. So the perpendicular height. Okay, so area equals half the sum of the parallel sides. So the parallel sides are x plus 4 and 3x plus 2. Let me just write that a little bit better. 3x plus 2. So half sum of the parallel sides. So this and this are the parallel sides, right? These, they are parallel. Okay, half times the sum of the parallel sides times the perpendicular height, which is x plus 1. We know it's perpendicular because we see that there. That tells us it's perpendicular. So times the perpendicular height. So that equals the area. And the area, they told us, is 15. 15. Everything is in centimeters, So we don't have to take into account to do any conversions. We can just do this and now simplify. Okay, but yeah, actually let's complete this one first and then we'll look at the other method. Okay, now, so I would first probably, let's say multiply by 2 first. So if we multiply by 2, the half goes away this side, other side becomes 30. And then maybe in one step as well, I would simplify this bracket. So out of the like terms, x plus 3x is 4x. And then 4 plus 2 is 6. Okay, and then we've got x plus 1. Now I would multiply out the brackets on the right. So 4x times x is 4x squared. Then 4x times 1 is 4x. 6 times x is 6x. And then 4x plus 6x is 10x. And then 6 times 1 is 6. And now, let's take everything to one side equal to 0. So 4x squared plus 10x plus 6 minus 30, so that's going to be minus 24. And now we can still divide everything by 2, just to simplify it a bit. Okay, so 0 equals, 0 divided by 2 remains 0. Remember to also divide the left-hand side. It just remains 0 because 0 divided by 2 is still 0. If we divide this by 2, we get 2x squared. Next term by 2, we get 5x. And the next term by 2, we get negative 12. And that is exactly what they wanted. Boom. Success. Now, let's see what would happen if we split this into a triangle and a rectangle. Let me just find where are my shapes. A line. There we go. I'm going to put a line down here. And now we need to find out what is this length. So if this whole part, if this whole length is 3x plus 2, and this part at the top is x plus 4, then this length is the 3x minus 2 minus the x plus 4. Okay, so over here, we have the 3x plus 2 minus the x plus 4. Okay, so that gives us 3x minus x is 2x. And then 2 minus 4 is negative 2. So this is 2x minus 2, this little part here. This part is obviously also x plus 1, because it's exactly the same as that. Okay, just to make it less confusing, let me erase this part here. So I hope you're fine with how we got 2x minus 2. Right? So if we, 2x minus 2, if we add it to that, we get the 3x plus 2. Okay, so let's do area of the triangle first. So area of a triangle, area of a triangle is half times the base times the perpendicular height. And the area of a rectangle is length times width, or base times height, however you want to see it. Okay, let's start with the area of the triangle. So that area of the triangle is going to be half times the base. Let me just say the total area is 15. Okay, so first the triangle part. So that's half times the base times the perpendicular height. And then to that we add the area of the rectangle. The rectangle is length times width. The x plus 4 times x plus 1. X plus 4 times x plus 1. Okay, let's simplify. So in this case, I'm just to show that it doesn't matter exactly what we do first, I'm going to multiply the half into this bracket. So half times 2x is x, and half times negative 2 is negative 1. Okay, and then we still have that same bracket here, and we still have these same brackets. Oops, x plus 1. Okay, now let's multiply out the brackets. Okay, so x times x is x squared. X times 1 is 1x. Negative 1 times x is negative x, so they cancel out. And then negative 1 times 1 is negative 1. Okay, then multiply these out. X times x is x squared. And then x times 1 is 1x. 4 times x is 4x. 1x plus 4x is 5x. And then 4 times 1 is 4. Okay, again, collect like terms. get everything to the other side. So the x squared plus x squared is 2x squared. Then all the x's, which is a 5x. And then all the numbers. We've got -1 plus 4, which is 3, and then minus 15. So 3 minus 15, -12. Okay, so you see that also works. And I'm sure there are many other ways you could also do it. But those are the two most obvious ones that I thought of. Okay, now we have to solve this equation. Okay, so again, let's check if we can factorize it. So how do we do that? We say the coefficient of the x squared times the constant. So 2 times -12 is -24. Now we find all the factor pairs that can give us 24. So 1 and 24, 2 and 12, 3 and 8, 4 and 6. Okay, and if we add or subtract these, we need to get the 5, the middle term here. So 3 and 8 can give us 5, right? If we say -3 plus 8, that does give us 5. Okay, so that part works. And then let's check if the multiplication works. So -3 times +8 is -24. That also works. Great. So now we can change this quadratic trinomial into a grouping factorization question, which is much easier. So how do we do that? Well, we rewrite the first two terms, the first term, and then instead of the 5x, we're going to write this, -3x plus 8x. You can also change it around. So -3x plus 8x. So that just replaces what we did write as 5x. It's exactly the same. And then still -12. Okay, so does that make sense? -3x plus 8x is also 5x. We just want to write it in this way because then our factorization will work very well. Okay, that's fine. I'm just going to erase this to make it look a little bit neater. Okay, so we do grouping. I always just group the first two together and then the last two. So these two, what can we take out here as a common factor? An x. And what are we left with? 2x minus 3. Now over here, we can take out a common factor of a 4. And we're left with 2x minus 3. Brilliant. Okay, let me just add the equal 0 that we had there. So equal 0. Now we have two terms. What is common between these two terms? Well, the bracket 2x minus 3. So now we can take that out as a common factor between these two terms. 2x minus 3. And what is left if we take out the 2x minus 3 from the first term? An x. And in the second term, a 4 is left. Okay, and now we know that either this must be equal to 0 or the other bracket must be equal to 0. Right, that's the only way we can get 0 if we multiply two things. One of the things at least must be 0. And we just solve both of them separately. Where's my thing? Okay, there it is. Okay, so this gives us 2x equals 3. And then we divide by 2. So x equals 3 over 2. Or, and this one, we just take the 4 over, it becomes -4. So there's our answer. X equals 3 over 2. Or x equals -4. And the beauty about mathematics is in very many cases, at least at this level, you can test your answers. You just take your calculator, plug in the answers you got here to see if you are correct. If you are correct, if they work, then you know your question is right. If they're not correct, then at least you know they're not correct. Then you can come back to it and solve it properly. Now write down the length of AB. Okay, so AB is 3x plus 2. Let me just write that down. So AB is 3x plus 2. So now we know what the possible values for x are, so we can just substitute those in. And if we substitute in the -4, we get 3 times -4 plus 2. -12 plus 2 equals -10. So our answer could be -10. But no, it cannot. Why can it not be -10? Cannot be -10 because we're working with a distance. You cannot have a distance less than 0. That does not make sense, right? So this one does not count. And if we substitute in the 3 over 2, what do we get then? Then we get 9 over 2 plus 2, which we can write as a fraction or as a decimal. So as a decimal, 9 over 2 is 4.5 plus 2, which gives us, 6.5. So 6.5 centimeters. Or, if we want to write it as a fraction, we can say that's 9 over 2 plus 4 over 2, which is 13 over 2. Okay, so you could also say 13 over 2 centimeters. But I think, if I remember correctly from marking exams, most people prefer to write this as a decimal. Fantastic. Question 4, we move on to probability. So for this one, let's do red. Okay, in this question, write any probability as a fraction. So don't write a percentage or a decimal. They ask for a fraction. And they also wrote it in bold, so we have no excuses for missing that. Joseph has 15 cards with a shape drawn on each card. Okay, of the 15 cards, 5 cards have a square, 6 have a triangle, and 4 have a circle. So 4 plus 6 is 10 plus 5, 15. So all 15 cards are accounted for. Okay, Joseph selects a card at random. Write down the probability that the card has a circle drawn on it. Okay, so he selects one card at random. So the probability of getting a circle is, how many circles are there? There are 4 cards with a circle. Out of how many total cards? 15. So that's it, 4 over 15. And remember to simplify your answer. It's silly to lose a mark if you don't simplify your answer. In this case, it's already simplified from the beginning. But let's say it was 5 over 15. If you had this, you would have had to simplify it to 1 over 3. Otherwise, you would not get your mark. So remember to simplify. Always simplify all the answers. Okay. Joseph selects a card at random and then replaces it. He does this 300 times. So he picks up a card, puts it back. Picks up a card, puts it back. Calculate the number of times make that a he, expects to select a card with a circle drawn on it. Okay, so we've already had the probability that one of the cards is a circle if he picks it. So we're just going to say we expected this fraction of the time. So that fraction of all the times, which is 300 times, it's going to be a circle. Okay, so we can just type that in the calculator. Again, pretty straightforward if we think about it. So 4 over 15. 4 over 15, and we do that 300 times. So 4/15 of all 300 times is 80 times that we expect him to get a circle. So 80 times. Now Joseph selects a card at random, replaces it, and then selects another card. Okay, so he picks up 2 cards, but he replaces the first one so that card is again drawable. Calculate the probability that one card has a square and the other has a circle. Okay, so let me quickly draw a picture. So for the 2 cards that he picks, one has a square and the other a circle. But we could also draw it the other way around, right? We could also first pick a circle card and then pick a square card. So we have to account for both of those. So it's this first one or that one. Okay, so we're going to say the probability of getting a square and then a circle, or getting a circle and then a square. Right? Those are the probabilities that one card has a circle and one has a square, because they don't tell us if it's a first or second. We have to account for both. Okay, so probability of getting a square on the first draw. How many squares do we have? 5. And then 4 circles. Okay, so 5 out of 15. The first one is a square. Then he replaces the card. So all the cards are there again. So the next one is circle, is all the probability of getting a circle. 4 circles out of the 15 card. And then we could just times it by 2 if it's a case like this. But just to show why we can, that this one will be exactly the same, is now if we start with the circle, that's 4 over 15, replaces that. Now what's the probability of getting a square? 5 out of the 15 cards now have a square on it. Okay, so we see it's exactly the same calculation. So we could just multiply the first one by 2. Okay. So we have 5 over 15 times 4 over 15. Okay, so that's that. 0.0. I was hoping this one would give us a fraction as an answer. Okay, I'm just going to write that as a fraction. It shouldn't be difficult to do. So we can simplify this to be 1 over 3. And then multiply 1 times 3, 1 times 4 at the top is 4. At the bottom, 3 times 15 is 45. And that's going to be the same for the other one if we do this again. 1 and 3, 1 times 4 is 4. And at the bottom, 15 times 3 is 45. So if we add those, we get 8 over 45. Okay, so 8 over 45. Now the same procedure, but now they ask, what is the probability that neither card has a circle drawn on it? So the cards must have everything except a circle, both cards. So different ways we can do this. So I'm going to say, if we write it out, it's going to be all these probabilities. So probability of getting triangle, or triangle square, or square triangle, or square square. Right, those are all the options that do not have a circle. So we just work out all of them. So probability of triangle is 6 out of 15. And then another triangle, 6 out of 15 again, because we replace the card each time, right? And now triangle, and then square, or square and then triangle, square and then triangle, oops, triangle 6, or square and then square again. Okay, and then we just do those calculations. Okay, so this is going to be 36 over 225 plus this is 30 over 225. This is 5 times 6 is also 30 over 225. And 5 times 5 is 25 over 225. Okay, let's add all the top parts together. So 30 plus 30 is 60. Plus 36 is 96 plus 25. What is 96 plus 25? 121. I think I'm just going to do this so I don't make a mistake. So 36, whoop, 36 plus 30 plus 30 plus 25. 121 indeed. Okay, so 121 over 225. And I don't think that can simplify. If it can, we do have to simplify. Let me just see if I can figure out if it does simplify. Doesn't look like it. Maybe. No, it doesn't look like it. Okay, so that's our probability that neither card has a circle in it. So all the options that don't include a circle, we have to take into account. So remember to take both ways around. Triangle then square, or square then triangle. Don't just do one of them, do both. Question D. Joseph selects 2 cards at random without replacement. So now he takes out a card and then takes out another card without replacing the first one. So that affects the probability of the second draw. He calculates the probability that only one card has a triangle drawn in it. So only one card a triangle. Okay, so again, that's going to be either triangle square or triangle circle or triangle triangle. No, triangle doesn't work. So triangle square, triangle circle, or the other way around. Square triangle or circle triangle. Okay, so we have to do all of these. But now remember the card is not replaced. So the probability that the first one is a triangle is 6 out of 15. Now, what's the probability that the second card is a square if we've already taken out one triangle? Well, the number of square cards remain the same because we didn't take out a square, but we did remove one of the cards. So 5 out of the remaining 14 cards have squares in them. Okay, or the other way around, which will end up being the same. So I'm just going to say times 2. Oh no, sorry. My bad. This is a circle. That's not the same. So plus, then, but this one again is the same. But it's fine. Okay, so first one is triangle, 6 over 15. And then the next one is circle, 4 out of the remaining 14. And now again, square and then triangle. So first one is square, it's 5 over 15. Next one a triangle, 6 over 14. Okay, and then again, circle, circle, and then triangle. Okay, and then we just calculate those. So again, 6 times 5 is 30, over and 15 times 14 is 210. Okay, so 30 over 210. Times by 2 because this one is the same. So these two are the same, right? So we just times by 2. So that'll make it 60 over 216. By 210, I mean. Plus. Okay, so we've sorted those. Now let's do these ones. So 4 times 6 is 24. We times that by 2, we get 48. And again, 15 times 14 is 210. So we add this up, we get 108 over 210. And then we simplify that. I think both of them can be divided by 2. I think that's probably... No, they can both be divided by 9, maybe? Well, let's see. Divide by 2, we get 54 over 105. And we divide everything by 3 again. So dividing this by 3, we get 18. Dividing 105 by 3 is 35. And I think that is the final answer then. 18 over 35. Okay, let me just check. Is that correct so I don't lie to you? So if we said 108 over 210, that gives us 0.514. And 18 over 35. Yeah, that is correct. Same thing. Okay, fantastic. Now, we have to find the probability that the two cards have different shapes on them. Okay, so all the possibilities for different shapes. Okay, so I'm going to say this one I'm going to do slightly different. I'm going to say that's the same as 1 minus the probability of all of them having the same shapes. So 1 minus triangle, triangle, so that's the same. Also, we want to get rid of, we don't want to count square, square, and we don't want to count circle, circle. All the other ones we can count. So I think this will be a little bit faster than listing all the other shapes. Okay, so 1 minus probability of triangle, triangle. So triangle on the first one. Now the triangle on the second one again. So we've removed one of the triangles and one of the cards total. Squares, we'll do the same idea. So square on the first one. Now we've removed one of those square cards. So only 4 squares out of the 14 cards left are squares. And circle, circle. So the first one is a circle is 4 out of 15. And then the next one is again a circle is only 3 out of the remaining 14 cards. Okay, so 1 minus 6 times 5 is 30 over 210. Minus 5 times 4 is 20 over 210. And 4 times 3 is 12 over 210. So 1 is the same as 210 over 210. Okay, so 210 minus the 30 minus 20 minus 12 over 210. Okay, I actually shouldn't write it like that. That's going to look wrong. Okay, let me just type this. So 210 minus 30 minus 20 minus 12. So 148 over 210. 148 over 210. Again, both of them can be divided by 2, which gives us 74 over 105. And I think that's probably the simplest form, but if it's not, I apologize. I'm sure you'll correct me in the comments. Question 5. Okay, the diagram shows the sector of a circle. Let's go back to blue. Shows the sector of a circle with center O and radius of 24. The total perimeter of the sector, so that total outside length, is 68 centimeters. Find the value of x. Okay, to find the value of x, so we know that's 24. That is also a radius, so that's also 24. Which means that's 48. So we need another 20 here to make the 68, right? And now we can use this arc length to find the sector angle. So we're going to say the arc length, that's just some fraction of a full circle, right? So what fraction? This fraction out of 360 of a full circle. So this fraction of a full circle times 2 pi radius, right? Because 2 pi radius is the perimeter. Make sure right there. Perimeter equals 2 pi radius. Area equals pi radius squared for a circle. Right, so now we're just taking some fraction of the full perimeter, and it's this fraction of 2 pi r, and the radius is 24. So that fraction of a full circle has a value of 68, they tell us. Right? Not actually 68, 20 we calculated. So 68 is for the full circumference of the sector. 20 is this fraction of what the full circle's perimeter would be, right? So this whole thing would be 2 pi r. Now it's x over 360 times 2 pi r to get the 20. Okay, now we just need to solve for x. So first, I would say I would do 2 times 24 is 48 over 360, or I would just say, let me actually show the steps here. So I would say I'll multiply by 360 first, but I would probably do all of this in the calculator in one go. But I'll multiply by the 360. So 20 times 360, 7,200. And then I would divide by 48 pi. So 7,200 over 48 pi. Okay, 7,200 divided by, let me just put it in brackets to make sure, 48 pi. Where's the pi button? There we go. So 47.746. So 47.746 degrees. And now we have to see where do we have to round this off? They don't tell us in the question, but that's where it's important to read this. If the degree of accuracy is not specified in the question, and if the answer is not exact, give your answer to 3 significant figures. And for answers in degrees, we do 1 decimal place. Okay, so we get told 1 decimal place for angles in degrees. We're going to round this off to 47.7 degrees. 47.7 degrees. Okay, the points A and B of the sector. So here, A and B, they join it together. Imagine how that works to form a cone like this. So A and B are like this part here is now joined together. Okay, calculate the volume of the cone. The nice thing is, we don't need to know the formula for a volume of the cone. They give that to us. We need to know the formulas for any prism. We need to be able to calculate that and know the formulas. Anything that's not a prism, like spheres or cones or other irregular shapes, they might give us the formula for in the exam. Okay, so third, pi r squared times h. So what's the problem? We don't know the radius of this, and we also don't know the height. Okay, so from O to AB, so O to this, we know that's 24. So let's write that in. We know this is 24. Okay, this A to B part here, this is now the circumference of this circle. Right, so that's the circumference here of this circle. 20 equals the circumference. Okay, so we can use that to find the radius. So let's say that's the radius. So radius, circumference equals 2 pi r. To find the radius, we can divide 20 by 2 pi. That's r. Okay, so our radius is 20 divided by 2 pi, which is just the same as 10 over pi. I'm just going to write it as 10 over pi, so I don't have to use rounded off decimals. So that's the radius. Okay, now we still need the height. But we can find the height using Pythagoras' theorem. So this is a bit of an involved question, quite a few things to take into account. because that makes a nice right angle. So we need this one. So Pythagoras' theorem states that if we have a triangle like this, that's A and B and C, then we know that A squared plus B squared equals C squared. So we'll do exactly the same thing here. Let's just call this H, because we don't know what it is, right? We're going to say H squared plus 10 over pi squared equals 24 squared. Okay, so we solve for H. So H squared equals 24 squared minus 10 over pi squared. And then we just take the square root of that. So the square root of 24 squared minus, 10 over pi squared. Okay, we'll type that in the calculator because that, I think, would be useful to round off. So we've got the square root of, then 24 squared, which is 576, minus, and then 10 squared is 100 over, and then I'm just going to put extra brackets just to make sure, because I don't know how this calculator reacts to everything. Squared. Okay, so 23.79, or 23.8 if we use three significant figures, right? 23.8 centimeters. That's our height. Okay. Now, let's do this. So volume of the cone is 1/3 times pi times the radius, which we said is 10 over pi, squared times the perpendicular height, which is the 23.8. Again, actually, since it's not a final answer, we're not allowed to round that off yet. We have to use this whole thing since it's not a final answer. And let me just erase here, and then we can use the whole thing. Okay, that's the volume. Let's use that in our calculator again. So we have 1/3. Whoa, where did I go here? Equals. Okay, so we have 1/3 times pi squared, and then times that. Third pi, no, not pi squared, pi times radius squared, sorry. The radius is the 10 over pi. 10 over pi squared. Okay, equals, so 252 point something something something, so three significant figures, 252. So 252, and all this was centimeters. That's centimeters cubed, right? Centimeters, yes, so this is centimeters cubed. Okay, and again, if you have a different way to do it, please let me know. I love seeing different ways of solving the same question. Okay, 252. Okay, they gave us a lot of space, 6 marks, so definitely supposed to be a bit of a more tricky question, and I can see why. Because we had to know we can use the circumference to find the radius. Then we had to know we could use Pythagoras to find this height. And only then could we use this formula. So definitely a little bit more of a tricky one. Question B. I think we're almost there. Let me see. Yeah, so question B, and then we've got one on statistics, and then we're done. Question B here, the diagram shows the shape made of a square, a quarter circle, and a semicircle. OPXY is the square of side A. Okay, they give us that. OPQ is center O. OMQ is the diameter of the semicircle. Okay, fine. We have everything we need. Calculate the area of the shape. Okay, so area of a square is just side times side. So we know that's 8 as well. So 8 times 8, 64. Okay, square centimeters. Now, for this quarter circle, because that's 90 degrees, right? It's a quarter circle. So it's just 1/4 of a full circle's area. And the area of a circle is pi radius squared. So it's just 1/4 of this that we have here. So pi times then the radius, if that's the center, then this is the radius, right? So pi times radius squared divided by 4. It's 1/4 of that. And then a semicircle, so it'll be half of this pi radius squared. So the radius of this circle, if that's the center, is half of 8, right? So that's 4. So pi times radius squared, but divided by 2 because it's half of this circle. Okay, now we just add those together. Okay, I'm just going to simplify them a little bit. I'm going to say, so it's 64 plus 8 squared is 64. 64 divided by 4 is 16. So 16 pi. Where's my pen? Okay, 16 pi. And then for this one, 4 squared is 16. 16 divided by 2 is 8. So plus 8 pi. Collect the like terms. So we've got 64 plus 24 pi. Okay, 64 plus 24 pi. We just write it down here again. Plus 24 pi. And then let's put it in the calculator to round it off. So 64 plus 24 pi. 139. That's 139 centimeters squared. Remember your units. Okay, last question, question 6. So here we have a table that shows the height, h centimeters, of 40 kids in a class. Again, then it's displayed in a sort of a cumulative frequency or a frequency diagram here. What will we switch to? Does bright green work? Can we see that? Yeah, we can see that. Okay, let's do that. Okay, write down the class interval containing the median. So the median is the middle number. So let's just accumulate. So the middle number, if we have 40 kids, is going to be the 20th number. So we're looking for which one of these intervals has the 20th number. It's already arranged from small to large for us. So we just do the cumulative frequency. So cumulative frequency will be 3, and then 3 plus 14 is 17. 17 plus 4 is 21. Okay, so I'm just going to continue, but we already have the median class. 21 plus 6 is 27, and 27 plus 13 is 40. So if the 20th number is not in these values yet, but this class ends on the 21st number, that means the 20th one must be in this class, in that interval. So it will be this interval, the from 140 to 144. Okay, in there will be the middle number, the median. Now calculate an estimate of the mean. Okay, to do that, we first need, okay, now I'm going to erase again, because probably want to use that space. So we want the midpoint of each interval here. So halfway between 120 and 130 is 125. And then 135 for this one. Between 140 and 144 is 142. 144 to 150 is 147. Between 150 and 170 is 160. Okay, so those are the midpoints. Then we do the midpoint times the frequency. Oops. So here. So we're going to do frequency multiplied by the midpoint. Okay, so 125 times 3. That's 375, but I'm just going to put out the calculator for this one. 125 times 3, 375. Okay, then 135 times 14. So 135 times 14, 1890. 142 times 4, 568. 147 times 6. Oops. 147 times 6, 882. And finally here, 160 times 13 is 2080. 2008. Keep on losing my pen. There we go, 2080. Okay, so we want to add all of those together. So let me just say, so the estimate of the mean, we can say that's the sum of the frequency times the midpoint divided by the total frequency, the sum of the frequency. That's how I can write it as n, or I can say that is also the sum of the frequency. Okay, so if we add the frequency times the midpoints together, that's going to be all of these values added together, right? So that's going to be the 2080 plus the 882 plus the 568 plus the 1890 plus the 375. Oops, 375. 5795. 5795. We divided by the 40, the sum of the frequency. They told us what that is in any way, otherwise we just add all of those together to get the 40. That is our estimate of the mean, and in another video maybe we can go through why we can estimate the mean by doing this. Okay, 5795 divided by 40 gives us 144.875. $144.875. Okay, and again, that is the height in centimeters, so that is the average. Again, obviously you can also want to check, just do a sanity check, that the 144.875 is at least inside of this. It's not, can't be bigger than the biggest or smaller than the smallest. That makes sense that it's around here, right? That does work. Okay, complete the histogram. So histogram has frequency density on the one side and then the actual height over here. And the frequency itself will be the area of this shape. Okay, so let's just test this. Sometimes there can be a scale factor as well, but I don't think in this case it is. The area of this rectangle will be 10 times, and then there's 1, 2, 3, 4, 5, 6. So 0.05 is each of them, so 0.3. So 0.3 times 10 should be 3, and that is 3. Okay, that works, right? So to find what the frequency density is, you take the frequency divided by the class width. So how far is it between 130 and 140? That's 10. So we take the frequency, 14 divided by the class width, 10. 14 divided by 10 is 1.4. Okay, so we have to draw this all the way up to 1.4. So 1.4, what is that? Let's see. So 0.4 divided by 0.05. It's 8, so we have to go 8 little blocks up here. That's 10, 9, 8. So there. Okay, I'm going to draw it with a nice straight line. Okay. Up to here and down again. Oh, why is it difficult to draw a straight line? Okay, that's good. Okay, good. Now let's do the next one. So the next interval is from 140 to 144. So that's a 4 gap, right? 144 minus 40 is 4. So with 4 divided by 4 is 1. So this one has to go up to 1. So there's 1 up to 144. Okay, next interval. 6 divided by, and 144 to 156, so that's another 1. Here, from 144 to 150. And then, if we go to 150 to 170, so it's 20. So 13 divided by 20, that's 0.65, right? 13 divided by 20 is 0.65, indeed. So 0.65. So that's going to be 0.65, this third one. 1, 2, 3. That's all the way to 170. Okay, and there is our histogram. Now, in general, if you have this, you probably want to do a bit of shading for it. You want to, well, that's not a shading one. do we have a highlighter thing? Yeah. So let's do that. We want to just shade them a little bit so you can see. So, or if we, in an exam, you probably don't have the shaders. You just have your pen or pencil, and then you just want to do something like this. I draw some patterns just to make it easier to read, right? Okay, etc. So it doesn't really have, you don't really have to do it, but the nicer you make it, and the easier you make it to understand what you drew, to see the lines, the easier the markers will mark. Okay, histogram complete, and that is the end of this exam paper. Okay, I hope you found that useful, and we'll be back with a lot more work this year. We'll go through lots of homework, lots of all the tests that we write, we'll put on the channel, and we'll take it from there.